One of the key concepts in organic chemistry is this idea of hybridizing orbitals. And hybridizing orbitals is not very challenging once you accept a couple of key phenomena. I'm going to show you some balloon video or some balloon demonstrations in class about this, but let's take a look at 4 hydrogens. 4 hydrogens are just going to be spheres. And we're just going to draw 4 smallish spheres. Hydrogen's not a very big atom. It's not going to have a very big system around it. So these are our hydrogens. Just spheres. And then we're going to have our carbon. And our carbon valence shells, we have 4 valence electrons for carbon. And those 4 possible orbitals for carbon are going to be the 2s orbital, which is going to be bigger than the 1s orbital, the 2py, the 2px, and the 2pz orbital. Now, if we draw maybe some coordinates, Cartesian coordinates in here, might be a little easier to see the behavior of those atoms. And what we're going to do with these 4 orbitals is we're going to imagine that we just kind of smash them all together. And what comes out of that is this idea of hybridization. Now, if you have your modeling kit, grab an atom, grab one of the black spheres from your modeling kit, and some of those gray sticks, and put those gray sticks in the 4 parts of that carbon atom, and then grab 4 white balls and add those on. And what you've effectively drawn is methane, or what you've effectively built is methane. But I'm going to do a little bit different design here. We're going to imagine that we take all 4 of these atoms and we're going to build a box. And inside this box, right in the very center of this box, we're going to put our carbon nucleus. And as a result of trying to minimize the space around our carbon so that we can effectively put the most electron density around this thing in equivalent space, what we're going to want to do now is we're going to imagine that we have an orbital that touches this corner here, this corner here, this corner here, and this corner here. And so what we end up with are 4 new orbitals. Each one of these new orbitals is referred to as an sp3 orbital, and it looks like this. Each one of these orbitals extends out. Right here in the center is the carbon nucleus. And so there's one going to this side, one going to this side, one going to this side, and one going to this side. And as a result, this would be, say, the smallest box we would need to fully encapsulate this structure. Another way to represent this would be to look like this. Here's a carbon atom. We have one sp3 orbital pointing up. We have one this way, one this way, and then one in the back. And the shape for an sp3 carbon, an sp3 hybridized carbon, is known as tetrahedral. Take your modeling kit, build CH4, set it down on the table, and what you'll notice is that there are 3 hydrogen atoms always resting on the table. But if you want to minimize the volume that you need to, say, ship this methane molecule to a friend in another state, you would need a box. And that box would allow you to put 1 hydrogen atom in this corner, 1 hydrogen atom in this corner, 1 hydrogen atom in this corner, and 1 hydrogen atom in that corner. And as a result of that, you have a tetrahedral shape. Now, if we try to draw a tetrahedral shape here, let's see if we can do it. Not quite right. I put 4 sides on the bottom. It should be 3 sides on the bottom. So it should look like this. That's your tetrahedral shape for an sp3 carbon. Use your modeling kits to observe this. They are your lifesaver in this course. You can use your modeling kits at all times in this course. Quizzes, tests, homework, etc.